it equals to 0.055 hours. So this time is the time needed by the car to pass the train. Let's see the other question. He says, how far will the car have traveled in this time? You know that it will pass the train, which is 1.1, but the train is actually moving. So we want to know the distance of the ground, of the road covered by this car in this time. So the trick here is that we're going to use the real velocity, not the relative velocity. So he wants delta x, and delta x equals delta t multiplied by v, and this time this v will be v1, so it will be equal to 0.055 multiplied by 95 equals 0.055 multiplied by 95, 5.2 kilometers, and this is the answer of the question. At this interval of time, 0.055 hours, it will cover 5.2 kilometer of the road. So moving to the next definition, which is acceleration. It is the change of velocity per time interval. And another meaning, it means the rate of change of velocity. So the average velocity, the average acceleration, is the total change in velocity through certain time interval. So we say in this time, what was the total difference between the ending velocity and the starting velocity, and this is gonna be the average acceleration, just as we did with average velocity. And we have another problem. A sports car moving at constant speed travels 110 meters in 5 seconds. If it then brakes and comes to a stop in 4 seconds, what is the magnitude of its acceleration in meter per second squared? And actually we can divide this problem into two main sections, or two main parts. The first part, when the car was moving at a constant speed, which is 100 meter per 5 second, and we have here delta x and we have delta t, so we're gonna make delta v, we're gonna make v, which will then be the starting velocity, and when we start the second part, because it ends to stop, which is v equals 0. So and at this time we will see the average acceleration from v moving until it stops, and actually it will be in negative because it is decelerating. So let's see, let's first begin with the first section. 110 over 5. So v equals delta x over delta t, and let's write the givens, that delta t equals 5 and delta x equals I forgot, 110. So v will be 110 over 5 equals, I think, 55 meter per second, right? Yeah. No. Excuse me. I'm so bad in math. 110 divided by 5 equals 22 meter per second. So this velocity will be our starting velocity. We would call it v1 equals 22. And then let's begin the second part, which is breaking down, or stopping, meaning that it begins from velocity of 22 and then ends at v2 equals to 0, and all of that happened in an interval of time equal to 4 seconds. So in this time t equals 0, and now he wants to know the average acceleration, and we know that the average acceleration is the total difference in velocity over the total difference in time. So t equals 4, and actually it's delta t because it was the time interval of stopping. So acceleration equals to delta v over delta t equals v2 minus v1 over t2 minus t1, but we have the term delta t already, so it equals to 0 minus 22 over 4, so it will equal negative 22 over negative 22 over 4 equals negative 5.5. And saying negative meaning that the velocity was decreasing and it was stopping by the rate of negative 5.5 meter per second for each second, meter per second squared. So this is the average acceleration. I hope this was enough for you, and the next time we're gonna talk about the instantaneous acceleration and the free falling acceleration and gravity and few other problems. So I wish this was helpful for you, and if you have any questions, let's discuss it in our live meeting. Thank you and see you later.